So today we'll be talking about the contraction and relaxation cycle for the muscles. So hopefully after today you're able to take something that you didn't know and just keep it in the back of your mind in case you ever do need it. With the help of what I have currently learned in my Anatomy 1 class taught by Dr. Alexander, and from what I have gathered from outside sources, for example, lumumlearning.com, I will be able to teach you how a muscle repeatedly contracts and relaxes through the use of various components like troponin, which is a protein, muscle fibers, and energy, which we know as ATP. So, may I just start out with, boom, sun's out, guns out. Beautiful weather we have, take advantage of it because it's been so cold lately. I had to, had to show off the guns. Anyways, by the end of the day, I really hope you can understand how I can flex the muscles I wish I had. Which takes us to our first step. We have a total of 4 steps total for this contraction and relaxation process. However, according to my notes from Dr. Alexander, our initial step as a whole involves proteins like troponin, myosin, calcium ions, and energy. Energy is what we know as ATP, which is adenosine triphosphate, meaning there's 3 phosphate groups triphosphate. In order for all this to work, calcium ions, according to an online textbook that I found at an online anatomy textbook that I found at OpenText BC, calcium ions have to bind to a protein called troponin. This is crucial for the entire process to work. So once they bind to troponin, this allows the myosin head, which is seen above, to hydrolyze ATP. ATP is hydrolyzed, meaning we pull a phosphate group and it goes from adenosine triphosphate to ADP, which is the adenosine diphosphate. As seen above, we have ADP, which we have 2 phosphate groups, and then our singular phosphate group off to the side, which will be crucial for the next step. Which leads us to step 2. According to CourseHero.com, once the protein myosin, which is the myosin head right here, once the protein myosin is energized by hydrolyzing ATP, this allows for it to attach to the thin filament. The thin filament is composed of troponin and actin. Our thick filament is composed of myosin and tropomyosin. Tropomyosin isn't too important right now, but just know myosin. And according back to my lecture notes, the myosin head binds to the thin filament, and basically it just means that it attaches right here. When it attaches, it forms a cross bridge, which is a fancy word for just attaches. Once it attaches, it releases the extra phosphate group that we pulled previously in step 1. It's seen right here, the little phosphate group is getting released. The phosphate group being released is very crucial for the entire process of energy and to be able to contract as a whole. So the third step involves, according to my hardcover anatomy book by Tortoa and Derrickson, the third step is crucial and it involves the actual contraction taking place. The energy that is released allows for the myosin head to pivot, meaning it turns and it moves. When it pivots, it pulls on the thin filament that's attached above, and it pulls it closer towards a thick filament, meaning it contracts the muscle. This contraction is known as the power stroke. Without the power stroke, no movement would be possible, which is crucial for life. If we breathe, eat, sleep, talk, everything involves contractions of the muscles. The next slide is basically just showing the different types of contractions that we have. Just because I'm flexing does not mean that's the only type of contraction you have. Everything you do, whether it's turning your head, moving your eyes, wiggling your toes, it all revolves around the contractions of your muscles. Which leads me to our 4th and final step. So once we are contracted, we need to somehow get back to a state of relaxation. Otherwise, we would be in a constant state of contraction and we would have muscle spasms, put a lot of stress on our bodies, and whatnot. So our last step is very short and sweet. In order to get back to relaxation, our muscles have to relax, obviously. So our myosin head is still attached to our actin, which is our thin filament, and in order for that to be unattached and to unbind, our myosin head must attach, meaning it has to rebind to another ATP molecule, aka energy. It attaches to another energy molecule That way it can go back all the way to step 1 and relax because it lets go of the thin filament, sliding it back to its original part. So hopefully after today you were able to understand exactly how a muscle works and contracts and just learn something new. Because of this, I hope that you are able to go through every movement that you have and be like, wow, this is crazy interesting. I never knew this could happen so quickly. So I guess it's true when they say you learn something new every day. Thank you for listening to my talk, and